Another anecdotal reason that Spark and Scala together are both super interesting to learn at the moment is that Spark and Scala skills are in extremely high demand. If you don't know about it, there's actually this really cool developer survey that Stack Overflow does every year. And the 2016 survey results came out a few months ago, and something really cool happened in these results. Let's just go to the technology section of this survey and look at the top paying tech. And as we can see, the top paying tech in the US is actually both Spark and Scala together. So indeed, Spark and Scala skills are both in high demand. And it's a good thing you've already taken the Functional Programming Principles in Scala course, and now you're taking this Spark course, huh? So what are we going to learn in this course? Well, we'll see how the data parallel paradigm that we learned in the parallel programming course can be extended to the distributed case using Spark. So that's where we're going to start in some of the next lectures. Then we're going to cover Spark's programming model in depth. We're then going to go into distributing computation, how to do it, and how the cluster is actually laid out in Spark. We're then going to move on and spend quite a bit of time learning about how to improve performance in Spark, looking at stuff like data locality and how to avoid recomputation, and especially data shuffles in Spark. We're going to spend quite a bit of time trying to understand when data shuffles will occur. And finally, we're going to spend quite a bit of time diving into the relational operations available in the Spark SQL module. So learning how to use the relational operations on data frames and data sets, and also all of the benefits that they bring you, as well as a handful of limitations. So Spark is popular because it allows programmers to take advantage of massive resources, from a handful to hundreds or even thousands of compute nodes, and it allows programmers to do so in a way where writing distributed programs feels like writing regular programs. As we'll see throughout this course, this detail, writing programs that are distributed but which feel sequential, is very powerful. But it can also be the source of many headaches, as we'll discover. Assumptions that you've learned to make as a programmer while working on single machines have no longer hold on a cluster. And Spark does its best to make all kinds of smart decisions for us in order to ensure that our jobs run correctly all the way through. But as we'll see, we'll often need to understand a bit more about what's actually happening under the hood in Spark to get good performance out of it. So that's going to be a major theme of this entire course. So what are the prerequisites for this course? Well, it builds on the material taught in the previous Scala courses, so it would really be best if you've already taken the previous 3 Scala courses in the series. Those 3 courses are Principles of Functional Programming in Scala, Functional Program Design in Scala, and Parallel Programming in Scala. Though at minimum, some familiarity with Scala is required. The course is actually designed to connect to the Parallel Programming course that Viktor Kunchak and Alex Prokopets taught. So many of the concepts that were introduced there, I pick up on them and I extend those concepts to the distributed case. So it's also helpful to at least have some familiarity with sort of the concepts that were taught in the Parallel Programming course. What about books and other resources that could help you out in this course? Well, in the past year or so, several books covering Spark have emerged, and most of them teach Spark and Scala. A good book covering the basics is O'Reilly's Learning Spark, written by Holden Karau, Andy Konwinski, Patrick Wendell, and Matej Zaharia. Matej is now a professor who created Spark when he was a graduate student at Berkeley. Another book that does a good job of covering the basics of Spark is Manning's Spark in Action, which was published in 2017. It's full of examples, and it's another good resource for sort of getting into Spark for the first time if you're looking for a good book. Though for a book that goes into more detail on how to achieve good performance, the O'Reilly book called High Performance Spark, which is currently in development by Holden Karau and Rachel Warham, is an excellent resource. This book goes into more depth about precisely how Spark executes jobs and how one can use that knowledge to squeeze better performance out of your Spark jobs than we'll cover in this course. So if you're looking for more performance, that's a great book to pick up. And finally, for a more data science-focused look at Spark, O'Reilly's Advanced Analytics with Spark book, written by Sandy Ritza, Uri Lasserson, Sean Owen, and Joss Wills, is a good book to pick up. This book is full of example data science applications implemented in a functional style with a Spark, and many of its major modules, so modules like MLlib and GraphX, which we're not going to cover in this course. Further, the authors don't just stop at implementing the core algorithms, they go into detail about how to prepare and clean data and how to tune models in order to get good results. So it's really a good resource for general data science as well. I highly recommend this book if you're interested in mapping some of the things you learn in this class to concepts and algorithms from machine learning.